Hey everyone! Ever feel like you have a million things to do but maybe not quite enough strength or coffee to get through them all? Today's LeetCode problem felt a bit like that. Assigning tasks to workers, some needing a little extra boost. Stick around to see how we tackled it. This is day 35 of coding every day until I hit 1K subs. Today involved a quick tweak to the series script itself, and then diving into a challenging LeetCode problem involving resource allocation. Let's get into it. First up, I spent a little time working on the script that helps generate these videos. The commit message mentioned trying to improve web scraping, which is part of how I gather info. It wasn't a complete fix, seems like web scraping can be finicky, but hopefully made some back-end improvements for future videos. No code to show for this one, just a behind-the-scenes tweak. Alright, moving on to the main event. LeetCode problem 2071. Maximum number of tasks you can assign. Quick spoiler alert. The goal here is to find the maximum number of tasks we can assign to workers. Each task has a strength requirement, and each worker has a strength level. The catch? We have a limited number of magic pills that can boost a worker's strength, but each worker can only use one pill at most. We need to figure out the absolute maximum number of tasks we can complete, given these constraints. My first attempt involved binary search on the number of tasks, k. The check function tried a greedy approach. Process the k easiest tasks, from hardest to easiest. For each task, try assigning the strongest available worker without a pill. If that fails, try the weakest available worker with a pill. This greedy choice for pill usage turned out to be incorrect. Sometimes using a pill on a slightly stronger worker is necessary to save the weakest for an even easier task later. My next wrong attempt also used binary search, but complicated the check function. It maintained a deque of workers strong enough without pills for the current task or harder ones already processed. It tried assigning from the deque, strongest first without pill, then weakest with pill. If the deque was empty, it had this extra logic to check the next strongest overall worker who wasn't strong enough without a pill, using a pill. This logic was also flawed and overly complex compared to the correct approach. Alright, let's look at the accepted solution. The overall structure utilizes binary search to find the maximum number of tasks k that can be assigned. We search in the range from 0 to the minimum of the number of tasks and workers. The core logic resides within the check function, which determines if a specific k is possible. Notice the crucial initial sorting of both tasks and workers. This check function verifies if k, passed as mid tasks, can be completed. It simulates the assignment process using a greedy strategy combined with a deque. We iterate through the k easiest tasks, but from hardest mid one down to easiest Nero. We maintain a deque ws of the strongest k workers who could potentially handle the current tasks, even if needing a pill. The key is the greedy assignment. First, try the strongest available worker, ws.pop, if they can do it without a pill. If not, and pills remain, use a pill on the weakest available worker who is capable with the pill, ws.pop left. This preserves stronger workers and uses pills efficiently. The approach achieves roughly O(n) log n plus m log m time complexity, dominated by initial sorting, and OM space for the deque. And that's a wrap for day 35. We wrestled with that task assignment problem, learned about optimal greedy strategies with binary search, and tweaked the series script a bit. Let me know in the comments if you've encountered similar problems or have different approaches. If you enjoyed the video or found it helpful, please hit the like button and subscribe for more daily coding. And if you'd like to support the channel further, you can do so over at buymeaboba.com, link in the description. Thanks for watching, and see you tomorrow.